I didn't get a chance to go through my emails this morning. Did everybody, I know that I checked one email that a student sent to me outlining their designs that they had drawn up and the one that they had chosen and that they were going to go ahead and build. Did everybody else send those to me?
I didn't get mine sent.
Okay. If you didn't get your sent, get it sent to me right away so that I can start grading that first section. Now you should be well into the building phase and maybe even the testing phase of your bridge. So let's take a look at, can you turn off your microphone there in Stapleton so I don't get the feedback? Excellent, thank you. It's hard to speak when I'm hearing myself speak 2 seconds later. So what we want to do today is let's take a look at our sheet and see where we're at. I don't know the connection. There we go. So the things you should have mailed me would be your 3 drawings, and then your final drawing should be to me as well. At this point, if you haven't emailed me your 3 drawings or your final drawing, get those to me. Your final drawing should include all the specific parts drawn out. They have this page where you're listing out all the lengths of the members of your bridge, the little pieces of your bridge. And that is on the scale drawing of your final design here, and also the list of parts. So these 3 pages here that list your parts. Let me show you my screen so you can see what I'm looking at here. My screen is, my computer is in a funny place. Okay. Let's see if I can get this to show up here. Yeah, I can only get it on one screen too. Why can I only get it on one screen? We'll shoot you over this screen, I guess. It'll be kind of a funny angle, but let's see if we can focus on that. So you have these three sheets of paper that you are going to have all your measured out pieces of wood and plastic. If you're using any cable or any other parts, you're going to measure out each piece scale to scale so that you know exactly how you're going to cut it. You're going to have a drawing, a scale drawing of your bridge, whatever it is, where each little square on your chart here is going to have a particular length associated with it. So maybe every square on your graph paper is 1 inch or ½ an inch or whatever it is. You're going to have to set up a scale drawing. You might have to use some mathematics. For example, you might have to use the Pythagorean theorem if you have any triangles where you know the two square edges of the triangle and you don't know that longer side, which we call the hypotenuse, right? You might have to use that equation d squared plus e squared equals f squared, or however you want to call it. In any case, you should have a scale drawing of your design and a list of all the different pieces, and that should be mailed to me before you start building. And you should be starting to build today, so that drawing should get to me soon. So please get it to me and we will start grading this stuff and judging your progress here. At that point, once you have that design finished and mailed off to me, you should start building your bridge. That is this section here, starting on page 11 and 12, where they tell you how to measure and cut, drilling pieces, tell you how to build a drill jig. Remember that you don't want to drill directly through the wood or you might break the wood. It's very delicate, so be gentle with it. You need to put a piece of wood underneath it, something to secure it maybe, so on and so forth. Here they have two strips of wood that are glued or secured to a board, and then they put the strip of wood between them, and then they have these little measuring marks on here that help you to know where to drill the holes. So if you zoom into this really quick here, can kind of see, if I can get to that place. I think I went too far. Now I gotta get out of this so I can see what I'm doing here. Anyway, they have a little jig that holds everything still, so that they can drill the wood securely, but also it has marks on it, so they can drill the holes in the wood equal distances apart and everything. You can do that any way you want to, but the more precise you are about it, the better your bridge is going to be. If you just kind of hock it together, not very likely it's going to do what you want it to do. So here they talk about all the different things that you can do to build as you're building your bridge, different techniques and everything else. Once you have built the bridge, it is time to test it. And there are two things to test it for, of course. First of all, you want to be able to span the 18-inch divide. Go ahead and measure 18 inches between two desks or two tables, and then put your bridge on it. See that it spans the bridge, or spans the gap. If it doesn't span the gap, of course you got a problem. Then you also need to test it for the load. So how do you test it for the load? You need 2 pounds. I don't care what kind of weight you use, but it does need to be 2 pounds. You can get 2 pounds of hamburger from the store if you want, or you can use a 2-pound mass from your physics teacher on campus or something like that. But it does need to be 2 pounds. It either needs to be already pre-calibrated, or you should weigh it somewhere to see that it is 2 pounds. And you'll place the 2 pounds in the middle of the bridge. You can either set it on the bridge, or you can hang it from the bridge. But before you do that, you're going to need to measure deflection. So here they actually have a testing device, which we will not use. But you need to either place the 2 pounds on top of it, or hang it from the middle. It needs to be at the middle of the bridge. You need to measure where the bridge is, the height of the bridge, before and after you put the weight on. And that height of the bridge should not change more than 1/2 inch during the loading. So once the weight is on it, it should not go down more than 1/2 inch. If it goes down more than 1/2 inch, then you need to redesign. Okay? Redesign. Which means that you might have to add some strength to your bridge. You might change something. Instead of just having a plain piece of wood along the bottom, you might use an I-beam or something else like that. So, things to turn in, for sure still. We have our 3 alternative bridge design sheets. If you haven't turned those in, turn them in. You should have a final bridge design sheet that includes these member sheets that have the distances between holes and the lengths of the members, the joints that are in it. All these things should be filled in for your bridge. However many pieces you're going to use in wood, in plastic, in dowels, in wire, if you're going to use wire, and so on and so forth. Then your final drawing comes down here into these sheets here. These sheets have dimensions on them that you can use. And you can make your own. You can also make your own scale if you want to do that. And then they have a evaluation and revision for testing the bridge, right? Here they say at number 1 is to take a picture of the side of your bridge, and then you want to write pre-test evaluation on one of these sheets. You're going to make a copy of these sheets. Here they want you to answer some questions. Why do you think the bridge will fail at different parts of it? You should do that. Decide what are your weak points or whatever else. And then you're going to do it twice. You're going to do one beforehand and one after the fact, after you load it. And there's all these steps that you take, right? They have you improve the bridge and make a new design. You should do that. This is the next step here, right? This is the next step. The one thing I want you to pay attention to is on page, what page is this? 27 maybe? Near the end here. It's, page 27. They have this project evaluation rubric. And they have essentially 1, 2, 3, 4, 5, 6, 7, 8 things that you need to score. There's a place for the student to score and a place for the teacher to score. Meets design criteria. Needs to span, the 18-inch gap, and needs to be made of the parts that I gave you, so on and so forth. Performance. How did it perform? Did it hold the weight up? Did it bend too much? Whatever. Give yourself a score out of 15. Give yourself a score out of 15 for aesthetics. How did it look? The craftsmanship. How well was it put together? Student participation. How much did you participate? If you think you did everything you could, give yourself 10 points. If you think you could have done more, give yourself 8 or 9 points maybe. Whatever. The drawings and the sheets. How well do you think you did on the drawings and the sheets you turned in on the final report, and then you add them all up for total points? You fill that out, and then I'll come back and fill out how I think you did. When they talk about the report here, number 3, they have a concluding report. They also have a report on the total length of the materials used, so you're going to add up all the pieces of wood length, all the pieces of plastic, get a length, all the pieces of dowels and get a length, and you're going to report on how much you used. And then you're going to put together a report that summarizes your design process, your aesthetics, the efficiency, the performance, the whole project essentially in a report. Now, in that report, I want you to make it as short as possible, but make sure that you address everything that they ask you to address here, and that is a complete report. I didn't put a page number here because I think that you could possibly do this in as little as a page, but most likely it's going to take you 2 to 3 pages. If you did it in a single page, you would have to take a really good writer to do that. And I think that I might be able to do it in a single page, but I probably would spill over into a second page. And I've done this kind of writing a lot. Most students, I'm thinking 2 to 3 pages at least. So think about a 2 to 3 page report in your final report, but still you've got to build the bridge and test it, so you've got some other things to do. These last pages after that are about building a drilling rig, or drilling jig, so that you can drill your parts correctly. But by today, I should have from each of you your pre-design worksheets and your final design worksheets, and you should be building your bridge and testing or testing your bridge today. So does anybody have any questions about where they're at, where they need to be at, what they need to be doing today? Does anybody have any questions about specific things about their design? Or any concerns about what you're doing, the parts you've got, or whatever else? All right, well, off you go. We have more design time today. By the end of the class period today, you should be working on stuff, working on building stuff, and maybe even testing stuff. So if you need to go off and work in a shop somewhere, that's fine, but get the work done. Make sure that you're taking pictures of things. They do say in here to take pictures and to do drawings. So make sure that you're whipping out your camera on your phone or whatever. If you don't have one of those, then maybe you can ask a teacher for a phone or use a camera on your on a computer. Most of your school computers can have a camera. You can use those to take pictures. One way or the other, let's fill out these worksheets. Let's finish our designs so that next time we can finish up the project. I'll be here if you have any questions. Now, are you working on yours at home, Tyler?
Yeah, my dad's got a pretty good collection of tools I can use.
Okay.
I was kind of out of town for the weekend, so I didn't really have the opportunity to work on it.
Okay. You have some drawings for me?
Yes.
Thanks.
First one's one I'll be going with. It's just a simple trestle bridge, but I'll be using I-beams for the base.
Okay.
The second one is, the idea was 3 layers of I-beams, 2 layers going this way, and then 1 layer going the other direction.
Okay.
So
Yeah.
double trestle.
Truss bridge. Okay. This is the one you're gonna go with?
Yeah.
Okay, so this is the one that you need to make your scale drawing with.
Actually, that one is a scale, because
But the-
it's for every centimeter, it's a centimeter to the inch.
Except that your scale drawing is lines, and you're not using infinitesimally small things, so you need to actually draw out the thickness of the wood, the size of the I-beams, the shape of the I-beams. All those things need to be a very specifically drawn. If you look on page, let's see, where's the example that we show here?
That's really a computer.
But they have one somewhere here that actually shows thicknesses. It's not here. But make another drawing on the scale drawing sheet. So there's another sheet here. It's right here. That's the revised version. It's right here. So they have these several sheets of layout sheets, these metric bridge layout sheets, which are after the alternative bridge design sheets. And you're going to lay out your bridge on here essentially piece by piece. Okay?
So we draw like each piece individually, or?
Yeah, well, you're going to draw them
to scale.
yeah, truly to scale, so that it's not just a line bridge, right? Yeah, and draw in the dowels, where the dowels are going to be. You want this so you can do that? Or?
Yeah, probably like that.
Okay. Okay, you can go ahead and use that to draw your next one, and use these sheets that are on page 21. Start on page 21 to do that.
Right.
They give you 3 sheets to cover it. You do, well, 4 sheets actually. Give you lots of sheets that you can glue them all together to make one big sheet if you want. However you want to do it.
It's kind of what I was thinking, but we could figure out if we have wood glue at home or something. Then you go get some.
I have wood glue here if you need it.
Would it be alright if I got gone? I'm in an awkward situation if my little sister didn't have school today, so she's in the student lounge right now by herself.
Well, you can always bring her up here if you want to.
That's right. I'll just go out and sit with her.
All right.
Get to work on that drawing.
Well, yeah, but the, right, they're gonna be built in AA. If that's what they're doing. You're exactly right, that's why we go through this, so right, the AS is already, there's like a real science maps. If you know what this is, yeah, right, well, that's the problem, right, you're gonna have 2 more years, right? Yeah, no, you're exactly right. She was, and hopefully, I mean, of course, she'll want to get the advice for the track. She said, oh, my life. Right. Yeah. Exactly. So I'm tired of get an AA and then take another math class and get a B. Right. Right. But not only that, not just yeah, she wants to raise it. You bet. We'll take her under for as long as she wants off. Yeah, that'll be one of the other. We give it a change, we get this in capital. Anybody that's a freshman now, still have the old. Also, the oriented, right. But they have to be a freshman. Right, they couldn't be a sophomore. Like, she's probably so good at that works. No, if anybody that's a sophomore next year, right, if anybody that's a freshman next year, will have could be, well, it's a catalog you print. Right. That's what it is. You just go off the catalog you print it. But you already have an associate working. Part of it is where it's out there for maybe they are. So you see well, they also it's not really science. Yeah, I imagine that. It isn't. This is no science. It is. They have to stand up and get a degree in social science and have some degree and another thing. And they're like, thanks. I just had to vent. Well, there.
You guys good? Yes. Yes, you're more than welcome to leave when you need to. Have a good one.